Good morning, everyone. My name is Ryusei Komatsu from Suwa University of Science. Today I will present our research titled Constructing a Web-Based Investment Simulation Platform for Educational Use in Financial Literacy. I will begin with the motivation for this study, then introduce the theoretical background, system design, evaluation results, and finally our conclusions and directions for future research. I will also take a few moments to highlight why this topic is particularly important in the Japanese context. In Japan, financial literacy education has lagged behind compared to many developed countries. Only around 7% to 10% of Japanese students receive financial education during school, compared to about 20% in the U.S. This gap means that many adults enter the workforce without the necessary understanding of savings, investments, or risk management. The Japanese government promotes the slogan "from savings to investment," but without education, this slogan cannot become reality. Therefore, the motivation of this study is to design a learning support system that is both engaging and effective, combining e-learning with a simulator. This approach aims not only to teach knowledge but also to change attitudes toward finance. Previous studies showed several important points. First, many learners dislike logical thinking and calculation in economics. Second, game-based and experiential learning have been found effective in motivating students. For example, studies show a correlation between game orientation and future planning orientation with improved financial literacy. Other studies demonstrated that video learning and quizzes can consolidate knowledge. Our research is positioned at the intersection of these two approaches, traditional video learning and interactive simulation. By building a system that integrates both, we aim to leverage the strengths of each method. The methodology combines several technical components. We applied the Granger causality test to determine relationships between economic indicators and stock data. We used geometric Brownian motion to generate random but realistic price movements, and Cholesky decomposition to ensure correlations matched real data. Finally, we employed the Informer model, a transformer-based architecture optimized for time series forecasting, to predict future asset trends. By integrating these methods, we ensured the simulator is not only educational but also technically credible. This design choice demonstrates to students that finance and data science are closely connected. The system is composed of three major parts: video lessons, quizzes, and a simulator. The videos provide foundational knowledge. Quizzes test comprehension and ensure a minimum level of understanding before progressing. Finally, the simulator allows learners to apply knowledge in practice. Teachers can monitor progress, and students who do not achieve at least 60% in quizzes cannot move on. This structure encourages serious learning while maintaining motivation through interactive elements. We prepared video materials in three major areas: financial assets, life planning, and risk management. Each area includes 3 videos lasting 5 to 10 minutes. For example, financial assets cover the difference between investment and speculation, and how to understand stocks and bonds. Life planning videos discuss major life events, Social Security, and pensions. Risk management videos cover insurance types and how to choose policies. Altogether, these videos create a foundation of practical knowledge, closely aligned with the official financial literacy map published by the Financial Services Agency in Japan. We conducted a pre-test and post-test evaluation with fourth-year students. Before using the system, the average score was 18.8 points. After learning, the average increased to 26.4 points, with a smaller standard deviation. This means not only did students improve individually, but the group as a whole became more consistent. Looking more closely, some areas improved dramatically, like basics of economics, which rose from 61.8% to 98.2% accuracy. Others, like stocks and bonds, improved less, from 60.0% to 74.3%. This shows the system works well overall, but some advanced concepts may require more support materials. The simulator was built using Python and Django. We collected data from Yahoo Finance and eStat, including stock prices, exchange rates, commodities, and macroeconomic indicators. Random data was generated with stochastic processes, then adjusted with Cholesky decomposition to preserve real-world correlations. The simulator thus provides learners with realistic yet safe opportunities to experience investment. The technical infrastructure also ensures scalability, meaning the system could be deployed for many students simultaneously. The Informer model was used for forecasting. It is a transformer variant designed for efficiency in long-time series. We trained it with historical stock and economic data and applied it to Bitcoin prediction as a case study. Although the mean absolute percentage error rate was about 0.17, which is not perfect, the model captured the general upward and downward trends. This balance between realism and approximation is sufficient for educational purposes, because the simulator is meant to teach concepts rather than provide precise trading signals. Our evaluation included both comprehension tests and questionnaires. The simulator succeeded in sparking student interest in investment, even among those who had little prior knowledge. However, the system revealed challenges. For example, indicators like PBR and dividend yield were difficult for students to memorize and apply. Also, game-style simulations sometimes distracted from theoretical learning. Thus, while the simulator is a powerful tool for motivation, it should be complemented by lectures and teacher guidance to ensure deep comprehension. In conclusion, we developed and tested an e-learning system that combines videos, quizzes, and a simulator. Results show improved knowledge, greater interest, and positive engagement in financial literacy education. However, challenges remain: how to deepen understanding of complex financial indicators, and how to balance fun with learning. For future work, we plan to refine the user interface, add a reset function for simulations, and extend the system to high schools. We also aim to expand research by integrating more advanced prediction models and improving feedback for learners. Ultimately, this project is part of a broader effort to ensure the next generation in Japan has the tools and confidence to manage their financial futures. Thank you for your kind attention.